Hello everyone. Today I'll be discussing disc clutches, the purpose of disc clutches, and the components related to disc clutches. Friction is a big component in this unit, especially with disc clutches. So many people may be wondering, is it a good thing or a bad thing? Are we for friction or against friction when talking about disc clutches? So we'll be finding out more about that in the next slide. So friction is actually considered an enemy. So friction is considered an enemy because it encourages energy loss or power loss, decreased efficiency of resistance, and wear. So wear occurs as friction itself wears the surface or the heat generated. This becomes damaging towards the different components. There are some components which rely on friction in order for them to operate or function, and in this case, it would be clutches and brakes, like brake pads. So our main objectives is to maximize, uniform, and minimize. So for maximize, the first objective would be this, and it's to maximize the friction coefficient because the higher the friction coefficient, the higher the power capacity of these components. The second objective is uniform. So we want to keep the friction coefficient uniform over a wide range of operating conditions like temperature, airflow, etc. And finally, the last objective is to minimize wear. This happens because if wear is happening very quickly, the components will fail very fast. So as discussed in the previous slide, with friction, a very good example would be the brake pads because of the material of the brake pads, it wears periodically, right? So that means you have to change your brake pads quite often. So now with the introduction and objectives out of the way, we can start with what is the function of the clutch. The function of a clutch is to permit smooth, gradual connection and disconnection of two members having a common axis of rotation. So basically, we have an axis of rotation like a shaft, which rotates while connected to a power source like an engine or a motor, with the purpose of transmitting this power gradually and smoothly to another shaft. For the most part, both shafts have a common axis of rotation. To further demonstrate this, imagine we have gears and imagine each shaft having a different axis of rotation as if they are parallel but not on the same axis. Now imagine you have an axis with one gear at the end rotating at, let's say, 1000 RPM and another axis that is not rotating at all. Now with this idea, engaging these gears, lots of noise will occur and damage to both gears will probably occur. So maybe the shaft or maybe even more will be damaged from this. So this is why a clutch is important. It will help overcome this issue by making the connection between the members smooth and gradual. With that being said, since we're focusing on clutches, a friction type clutch, now we'll be looking at the different requirements that must be satisfied for all friction type clutches. So the first requirement is the friction torque must be produced by an acceptable actuating force. The second requirement is that energy converted to friction heat must be dissipated without producing destructively high temperatures. And the third requirement is wear characteristics of the friction surfaces must be such that they give acceptable life. So now the basic kind of clutches that we'll be getting into are disc clutches. So sometimes you'll be looking for a higher power transmission capacity through the clutch, which can be achieved by multiple discs. So uh, this means that more power is being able to be transmitted from the driving shaft to the driven shaft. So these clutches can be designed to operate wet or dry. So now that we talked about that, automotive clutches for standard transmissions actually operate dry. whereas most multiple disc clutches, including the ones used in automatic transmissions, operate wet. So this will be the conclusion of my presentation regarding disc clutches. I hope you all learned something interesting today, and thank you all for watching.